Okay. Hi everyone and welcome to Math 027 Engineering Data Analysis. So let's get a brief overview first of the intended learning outcomes and topics. So for the first one, we want to compare the different key concepts and statistics, and then we want to compare descriptive statistics and inferential statistics, analyze scenarios, and extract necessary statistical concepts, and then differentiate between independent and dependent variables, and then classify variables or measurements according to their levels of measurements, and then contrast different methods of collecting data and its visualization. So we have an outline here. We will first discuss these concepts. Okay. So let's talk about what is statistics. So statistics is a way of getting information from data. And basically, that's it. So we have a data, and you will analyze this data in some way, and what information you could extract from that, that is basically statistics. So statistics formally is the branch of science that deals with the collection, organization, analysis, interpretation, and presentation of data. So at every aspect of statistics, no, it will start from the collection of data, and then you will tabulate that data, and then you will perform some analysis on the data by getting let's say the average, no? And then you will interpret the data. So what does this mean? No, what does average mean? And then you can present also that data using graphs. All right. So again, no, statistics is a way of getting information from data. Therefore, the 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 bridge between data information is basically statistics. And statistics in general is a tool for creating new understanding from a set of numbers or a set of data. Now, so let's discuss another key concept in statistics, which is the population. So a population is a group of all the items of interest. No? So it is usually a large amount, no? And sometimes infinite, or in other words, no, to make things simple, it is not countable. So one example of that is the registered voters in the Philippines. No, it is countable since we have a data of this, and this is an example of population. Now, in contrast to the population, we have a sample. So a sample is a set of data drawn from the populations. So population is potentially large. Instead of getting everyone from the population, we could get a sample from the population. So an example of that is, let's say, we get 765 voters from all the voters in the Philippines. So the visual representation of population sample can be seen here. So again, the population is everything, and the sample is just a portion of the population. Now, let's see, for example, we have a research problem in which we want to determine the average expenditure of households in Metro Manila. So what is average expenditure? Basically, what or how much do they, let's say, what is their average salary now? I think that's what it means, expenditure. So the population of interest with regard to this will be the set of households in Metro Manila only, since that is your research problem. Now, if we do this again, but in Quezon City, therefore the population will be all the households in Quezon City. So this population, no, even though population, we incorporate this with people, it is not just for people. No? It could be also for different types of people, such as farmers. So an example of this is set of farmers in Central Zone, or possibly animals or objects. So an example of fish is the milkfish, or how many milkfish is cultured in Luzon, or the set of fluorescent bulbs manufactured for a month. Also, it is not limited to people, it could be those animals and objects. So let's analyze this scenario to extract this population of interest in the sample. So a doctor claims that 3 tablespoons of pure virgin coconut oil daily can reduce weight. To test the doctor's claim, researchers studied 2 groups of 25 women aged 35 to 40 or 35 to 40 years with weights 130 to 140 pounds. He administered the 3 tablespoons of pure virgin coconut oil daily for a period of 3 months to one group of women only. After 3 months, he weighed the 2 groups of women. So, what is the population of interest here? Okay, so the population of interest here will be every woman in Earth. No? So the doctor claims that it can reduce sorry. It is all the persons now aged 35 to 40 that ranges 130 to 140 pounds. Now, if you're asked also, what is the sample of this research? So instead of getting everyone to participate here, only 25 women will participate. Okay? So instead of everyone in the world, no, at the Earth, we will only study 25 women. So that is a sample, no? Only a portion of the population. Excuse me. So let's discuss a new concept that is related to population samples. So the first one is parameter. So this is the descriptive measure of a population. So population is linked to parameter. Okay, so any measure of the population is called a parameter, and then a statistic will be a descriptive measure of the sample. So population is to parameter, sample is to statistic. Okay, so to visualize this, if let's say we have a sample, no, from this right portion, anything that you measure there will be called a statistic. But if let's say we gather this sample from the population, every measure in the population will be called a parameter. So again, no, with our analysis, populations have parameters, samples have statistics. Okay, so consider the case where our population consists of 40 students in a statistic class. So we have a scenario, let's say for example, 40 students in a statistic class. So we want to gather, let's say, the parameter or a parametric or a parameter variable, for example only, no, but it could be any measure. So let's say we want to find the proportion of students in this class with iPad. So the proportion of students will be the ratio of the people that has iPad over the total number of students. So this is just an example. Now, suppose that among the 40 students, only 12 own an iPad. Therefore, our parameter for that case will be 12 over 40, which is 30, or 0.30 or 30%. Okay, yeah, so this is the parameter based on the population. So your population is the 40 students, your parameter is 30%, or that, based on what you want to figure out, based on the population. But let's say not all of the 40 students are available. Maybe most of them are absent. Only 10 students are present. So you can only take 10 students to participate on your survey to figure out how many people have an iPad versus the total people or the total students. So you can get a sample of 10 students and let's say 4 of them own the iPad. Then we cannot really compute the parameter P, but instead we could compute for the statistic P. No? So they are related, the statistic and the parameter, but the statistic will be just an approximation of the parameter, which will be notated with this hat. No? So p hat for statistic. So let's say, for example, again, we have 4 out of 10 of students that has iPad. So the statistic will be 0.40 or 40%. So as you can see here, assuming things are random, you could make some conclusions, no? You could imply some conclusions, even though you cannot get everyone's data. So we can relate this sample measurements into this population measurements. Okay, so it should be close. So this statistical measure versus the parameter measure. Okay, so another case, adding to this one, is that suppose we redefine the population as the collection of all the section of statistics classes, so that the class containing 40 students is now a sample of the new population. So instead of just one class, let's say every class in that school will be the population. So what is now that 0.30 or the 30%? So since this is now a sample, then it will be called a statistic. So depending on the perspective, it will be a parameter or a statistic. So knowing that we have a connection between population and the statistic, let's describe the two main branches of statistics. So the first branch is the descriptive statistics, which basically deals with presenting, organizing, and summarizing data. So that's it. You're just describing basically the data. Okay? And in contrast to that, I won't contrast it yet. But an example for describing a graph will be summarizing the data by the use of tables and graphs. Okay? And we're already familiar with probably with pie charts, bar graphs, but we could also construct a histogram, frequency distribution table, scatter plots. Now we could also find the measures of center and variability position, which are basically just the mean, median, mode, and range, and so on, etc. Okay, that is descriptive statistics. We are just describing the data. We are just visualizing the data. But in contrast to that, inferential statistics is a body of methods used to draw conclusions or inferences about the characteristics of populations based on the sample data. So inferential statistics is when you take a sample from a population, and then you analyze this sample and you create some conclusions to the population or even predictions of that sample. Okay, so in contrast to descriptive statistics, it's basically describing. Inferential statistics is predicting or drawing conclusions or inferencing. All right, so visualizing this, we have this right hand side of the sample and statistic, and then we create a connection through inference to the population. Now, so one example of this is, let's say you want to figure out what is the average height of the population of the Philippines. So in reality, you cannot really ask them one by one. And if you could do that too, you have to be fast, because after a year, a month, people would have grown higher. So instead of getting the data from everyone, we could just get a sample from a few. No, so we will talk about sampling later on. But let's say you could get a sample, you could get some idea on what do you call this? on what could be the average height of the population of the Philippines. Okay, so we are trying to create a conclusion based on the sample that is statistics, and the process is called statistical inference. Okay, so we use statistic or the measure of variables in samples to make inferences about the parameters, just like what I said before. And we can create a prediction or an estimate on the population based on that data. Okay? So one example of this will be when we are or during the elections, the news, so you can see the news, or sometimes the candidates do the survey, but in general, the news will cover a survey at which they ask a few people who will they vote as, let's say, for president. So in reality, you cannot really ask everyone, but you can sample a few of them, and you can make inferences about what the general public could be voting for. So it becomes feasible and it becomes easier to do. No? Okay, so another example could be, let's say this, based on studies, there's a significant difference between the new vaccine and the old vaccine in terms of preventing ICU visits. So ano yung ICU visits? So ICU visits, that is intensive care units, also meaning preventing critical conditions for infected patients. So we could try, to get data using a sample to see whether there is some relationship to this, or the old vaccine and the new vaccines efficacy. And then another thing would be, let's say, the hybrid learning versus the purely face-to-face setup. So maybe there is some advantage of hybrid learning versus traditional face-to-face. So we could get some conclusions based on what data we have right now. Okay. Okay, so let's try differentiating what type of statistics is involved in the following scenarios, whether it is descriptive statistics or inferential statistics. So one example here. So as a result of the ongoing war between Ukraine and Russia, gas supplies are rationed, so we can expect the price of gasoline to increase 25% next year. So we can expect, meaning it is creating some prediction. Therefore, we can say that this is inferential. Okay, another scenario. At least 5% of all fires reported last year in a certain city were deliberately set by arsonists. So this is just describing a statistical measure. So we can just say that this is descriptive. Okay. Of all patients who received this vaccine, 20% later developed significant side effects. So again, on the perspective of this person, he or she is just describing the data. So therefore, this is just descriptive. Okay, another one. As a result of a recent poll, an overwhelming majority of voting citizens approve of reviving the building of nuclear power plants. So therefore, descriptive. Okay, so they are just describing. This number 4 is not creating an inference or a conclusion or a prediction, so therefore this is descriptive. Okay, so let's get an overview of the or of what we do in statistics, which we will call later the statistical analysis. So we usually start with a question or idea at the top of this visual, and then we gather data based on what we want to know, and then we could not gather everything. We could cannot really ask everyone. We could not gather from everything. So we just gather some samples, and then we describe that sample through a variety of analysis methods, which we will discuss later on. And then after that, we could create some conclusions, which is inferential statistics, towards the population. So this is the connection of the research question, the gathering of data, sampling, descriptive statistics, and inferential statistics into the question or idea. So this is a cycle. Okay. So what is the rationale, or why do we have to conduct the sampling, no, in general, and why do we have to do statistics? So in general, we do this sampling, we do this statistical analysis because sometimes scenarios will be invisible. It will take a lot of time, so on. So it will be also in fact expensive. It is easier, of course, and cheaper to do this, and we cannot really guarantee 100%, even with even if it is true, no. I mean, if you can ask everyone in due time, no, you will face some challenges. So you just take a sample and create estimates from that sample. But however, such conclusions not going to be correct. So this is the downside of statistics. Inferential statistics will not always be 100% guaranteed. But how do we measure that reliability is the question. So are we confident that from this sample that this population is, this prediction for the sample, from the sample to the population, will be reliable? We have this thing called the confidence level and the significance level. So the confidence level is the proportion of times that an estimating procedure will be correct. So one example of this is we would say that 95%, or we have a confidence level of 95%, which basically means that it will be correct 90%, 95% of the time. Okay, so we cannot really guarantee what we cannot usually. We will not be able to have a confidence level of 100% every time, but that is the ceiling of 100%. And then if your confidence level is 0, then you have no confidence at all. So in contrast to that, an opposing level will be the significance level. Basically, this is complementary, no? Unitary complement itong confidence level and significance level, which means if your confidence level is 95%, the significance level is 5%. Okay? So you could be 5% wrong, no? Of the time. Okay? So if you add these two measures, the confidence level and the significance level, you will get 1. So 0.95 plus 0.05, you will get 1. All the time, they are unitary complements. If you add those two, you will get 1. Or 100% in percentage. Okay? So statistical analysis plays an important role in virtually all aspects across many disciplines. So this is not limited for engineering students. This could be relevant. This is extremely relevant for education, for business, and so on. Technology, whatever. Okay. So the beginning of our statistical analysis will be the statistical inquiry, which is the research. Usually, what are we trying to figure out, or in other words, a research question, a statistical inquiry. Okay, so I think that would be all, and you guys